Hi folks, today we're going to work on simplifying square roots. Now I understand this might not seem like it has anything to do with the quadratics and what we've been working on, but it does relate to it, and the next lesson after this you'll see how it all relates. But for right now we just need to work on some of these basics in dealing with square roots. Now there are some general rules that you need to know. The product property, you just need to know that the square root of a times b is equal to the square root of a times the square root of b. And that rule also works in reverse. So an example of that, the square root of 18 is equal to the square root of 9 times the square root of 2. And the reason we'd want to do that is because the square root of 9 is a perfect square. So the square root of 9 is 3, so we're able to break it down. The quotient property, again, working in both directions. So you have the square root of a over b. That can be broken down so you have two independent square roots. Square root of a on top, square root of b on bottom. So again, a reason you'd want to do that, an example would be here where you have the square root of 2 over 25. So you can break it up into square root of 2 over square root of 25. And that's a big deal because the square root of 25 is 5. And there's this little rule that says you cannot have square roots in the denominator. So we need to get rid of that somehow. Here we have one of our first examples where we have the square root of 80. Now what we're going to want to do with that is we're going to want to break that apart into two separate square roots. So the square root of one number times the square root of another number. Now one of these numbers we want to be the biggest possible perfect square that comes out of 80. So if you need to, you can start listing off all of the factors of 80. So 2 and 40, 4 and 20, and on and on and on. And you will find that 16 and 5 is the best breakdown you can get. So the square root of 16 is going to be 4. So this breaks down into the 4 times the square root of 5. And that's it. That's your answer. Okay, over here we have another one, the square root of 27, where we can break that down into a square root times a square root. And again, we want to try the biggest perfect square we can find, and you'll see that that's going to be a 9. So 9 times 3 is 27. So the square root of 9 is 3, and then we still have this square root of 3 that hasn't done anything. Now some of you will have calculators that can do this for you, and I think it's great. Just make sure that you know how the process works for you. Here we have another couple of examples. This one, here we have the square root of a fraction, a square root of 7 over 16. So we can break that up into two different square roots where the top is square rooted independently of the bottom. Now the reason that works out well on this particular one is because on the bottom the square root of 16 is 4. And on top we still have the square root of 7, and we can't really break that down anymore. So that's pretty much it. It's done, and that's our exact answer. This next one, square root of 6 times the square root of 21, neither one of them works real well apart from the other. There's no perfect square that would come out of 6. There's no perfect square that would come out of 21. So what we're going to want to do in this case is we're going to want to put them together. So we have the square root of 6 times 21, which would be the square root of 126. Now we can turn around and break that apart with a perfect square. And in this case, 9 would be the biggest perfect square that would go into it. So 9 times 14 is 126, and the square root of 9 is 3. So our answer is 3 times the square root of 14. Now the reason that we're doing this and we're not doing decimals is because these answers are exact. So if we were to plug in to a calculator square root of 7 divided by 4, we're going to get a decimal that goes on forever, and it's not going to be exact anymore. These answers are exact, which at times is what you need the most. Here we've got a couple more examples, and this first one is an example of what happens when we square root the top and bottom independently, but the bottom doesn't go anywhere. There's nothing happening. So in this case, what we want to do is we want to multiply top and bottom by that denominator again. So on top, we've got the square root of 5 times the square root of 7, which would be the square root of 35, over, on bottom, we have the square root of 7 times the square root of 7, or the square root of 49. Now if you take a look at the bottom, the square root of 49 is 7. And that's it. We can't go any further. The square root of 35, there are no perfect squares that break out of that, so this answer is done, and it is exact. We cannot have square roots in the denominators. That is one of those little unwritten rules that you need to keep in mind. Now, over here on the right, we have 8 over 2 plus the square root of 5. Now, we can't just do the same trick we did before with multiplying top and bottom by square root of 5, because it doesn't get us anywhere. So what we're going to need to do is multiply top and bottom by a thing called the conjugate. Now, the conjugate is just like the denominator, but only there's a slight sign change. So it's 2 minus square root of 5. And keep in mind we have to do that on both top and bottom. So we multiply top and bottom by 2 minus square root of 5. So now on the top, we can go ahead and distribute through. So 8 times 2 would be 16, minus 8 times square root of 5 is 8 square root of 5. On bottom, what we're going to need to do is FOIL this out. So first times first is 4. Outsides would be minus 2 root 5. Insides would be plus 2 root 5. And lasts would be negative square root 25. Now, I'm just going to focus on the bottom for a second. If we combine our like terms right here, negative 2 root 5 plus 2 root 5, they're just going to eliminate each other out. We don't even have to worry about them. Now here, this square root, the negative square root of 25 happens to be minus 5. So now on the bottom, we're going to have 4 minus 5, which would be negative 1. And on the top, we still have 16 minus 8 root 5. Now this answer is, for all intents and purposes, complete, but I'm not a fan of leaving it like this because this negative 1 can basically go in and do a sign change and we'd get rid of the fraction. So our actual answer is negative 16 plus 8 root 5. Okay, now there's another example down here. I will leave it blank. You can give it a try on your own. We can try it in class. It's up to you. That'll be all for this time period. So your assignment is going to be page 269, numbers 3 through 21. Good luck. We'll see you in class.